Well, hello everyone. We're doing 13.1, which is our area between two curves. So look at what they have here on the note packet. They're talking about which function is greater than the other. And you get this information from graphing them and looking at them. So basically, whatever function is graphed above the other function for your interval is what you have to write down first minus the second function. So when we do these, I'm going to do the first one by hand, and then the rest of them, there are some that you will have to use technology. It will tell you that. Like we don't have the antiderivative tools to do all of these by hand. Okay, it also talks about the Gini index of income concentration because that is an integral and it goes always with the 2 from 0 to 1 of whatever the x value is minus the function. Okay, so let's look at this first example. And this first example has two functions, 8x to the third minus 2 and y equals 0, which y equals 0, thank you. Very nice of you to have an easier function. I'm actually going to draw this over here. I was going to bring up Desmos and show you, but you know what? I'm pretty sure I can draw this fairly well. So this is at 2, -2, excuse me. And this is a little before 1, so it's gonna go like this. And oh, darn them. I, like, thought I was trying to draw a specific line or something there. Okay, and then we're looking at that shaded region. So look at this. Let's look at line 2. Let me make it a different color so we can see it. That's this line right here, right? So we have the red line. Let's do this one a little different color just because. Then we can call them red and purple. Okay, so in this section right here, which line is on top or the highest? The red line. Then this number here is only going 1, so 2, 3, 4, 5, 6. This all goes all the way up to 6, and I really, it goes extremely high. So you can see in this whole section, I'm not even gonna draw it all because that is curving very slowly upward to where that section is massive, okay? And so let me go back to black here. This, we're going to cut it off here at the 6, right? And we're going to cut it off at the 0. So we have two different regions. So we have to do two different integrals because in that second region, purple line is on top. And our rule is on our integral, our one on top has to be first. So we have to find where these two equations cross right here because we need to find where we're going to go from one integral to the next integral. So the way that we do that is we're going to set our functions equal to each other, and that's going to give us our break-even point. This should be something you've heard a lot in business, like where's the break-even point? It's where the functions equal each other. So we have to solve this x to the third. We'd add the 2 over, divide by the 8. So x to the third is going to equal 2/8, which is the same as 1/4. Then we take the third root, and x is going to equal the third root of 1/4, which is about 0.63. If the problem is allowing decimals, you can move forward with 0.63. If this is an important point, right? You're putting this into your functions. You probably want to use the third root of 1/4 in your calculator or like 5 or 6 decimals out. So otherwise you might miss the problem over something silly. And you can shoot me an email if it's, a quiz or a homework problem where, you put in you, you went out 3 decimals and you were off a little or something. You can send it to me. Now, being off a little is not doing the problem wrong. And then, oops, I figured out my issue, right? You want to be able to do your homework until over, just do the problem over if you did something wrong so that you understand what you did. So let's set up these two integrals. The first one is going to go from 0, which is our lowest number right here, right? And it's going to go to the third root of a fourth. And it's going to have the red function on top minus the purple function. okay, and that whole thing dx. And what we're going to do is we're going to add it to, so I wrote that a little big, the second function, which is going to start with the third root of 1/4, which is where they cross right here. It's about 0.63. It looks really close to 1, but it's maybe a little less close to 1 than I have there. And it goes to the 6. So did we cover from 0 to 6? Yes, we're saying 0 to this point where they cross the x value, and then that same x value to the 6. Now the second function is going to go from 8x to the third minus 2 is on top, minus the 0, okay, dx. And we need to now calculate these out. So we have a pretty easy antiderivative on these. So on the test, you'll have to do one by hand. So please, let's practice it here, okay? So our first function, we'll just call this one the first one, the antiderivative of that sucker. Well, I didn't reduce that, darn it. So this would really, right, become negative 8x to the third plus 2. And this one here would just stay the 8x to the third minus 2. So on that top function, antiderivative, keep your negative 8, x to the third now becomes a fourth. Now divide by that 4. What does your positive 2 become? It becomes a 2x plus c, but we don't have to use that, right? So we're here, and that's our antiderivative. We're going to evaluate this from 0 to the third root of a fourth. Okay, so we're here. I'm going to reduce this to be what? Negative 2x to the fourth plus 2x to put it into my calculator. So then I need to put that into my calculator with the 0, which is way easier. Oh, we get out 0. Put in 0 to that function, you get 0. Now we have to put in the ugliness, third root of a fourth. Okay, and so I definitely need my calculator. So I'm going to take out my calculator. I am going to put, oops, I got something. I'm like weird. Okay, where's okay, here we go. I was in something weird. Just a second. So I'm going to do negative 2, and I'm going to do a parenthesis of, under math, there's a third root if you're on a graphing calculator, right? Enter third root of 1 divided by 4 for 1/4. Then you get out of that third root, end your parenthesis, take that whole thing to the 4th power, and then I'm going to add 2 times that whole third root thing again. So math third root of 1 divided by 4, arrow over to get out of that, and I get 0.9449. Okay. So what did we do for this? We subtract those, top minus the bottom always, because that's our higher one, right? So this one will evaluate to, top number was 0.9449. Oops, I wrote it 9, minus the 0. So I get a total value of 0.9449. Okay, so then let's do that again with our second function. So our second integral is right here, right? This is our second one, and it's 8x to the third minus 2. So when we do the antiderivative, you're going to have the 8x to the fourth again, divided by 4, minus the 2 becomes a 2x, right? And we're going to now evaluate this one from the third root of 1/4. So we're starting right where we left off, and then we're going to the 6th, the top number. Okay, so if we rewrote this one, it's 2x to the fourth minus 2x, and we want to put in our third root of a fourth. Okay, so in my calculator, I'm going to hit second-hand function, and I want to type all that in again, and I'm going to switch my signs because these were just opposite signs of each other, and delete this. So I now have 2 times that third root of 1/4 to the fourth minus 2 times the third root of 1. So I get a negative 0.9449, which makes sense because one's the opposite signs of the other. Okay, so we're at that. And now we have to put in the 6. darn it, it's not a 0, which was super easy, but we're just gonna go 2 times 6 to the 4th power, minus 2 times 6, okay, is 2,580. So I'm gonna go over here and my top number is 2,580, and I'm gonna minus off my bottom number, okay? And so that is gonna end up being an addition, 0.9449. So I get a total of 2,580 point like 94. Okay, then together we add these because this was this one and this one added together. So the total final answer would be 0.9449 plus 2580.94. So I'm going to do that in the calculator, 0.99, and I get 2,581 point like 89-ish. Okay, and that's just going 2 decimals out. Cool. So not too bad, by hand, right? Really, we've done the antiderivative. It helps us reiterate why we're learning that. But these are definite integrals, so we can do them in the calculator. So let's do it in the calculator. I'm going to show you in Desmos purely because it comes up on my iPad extremely easy. Okay, so I'm going to hit functions over here in the corner. And on the functions, you see me scrolling. It doesn't show it as well as I'd like, but and then we hit that integral. It automatically comes up with a definite integral for the numbers because it doesn't do and indefinite because it's not a symbolic calculator. Okay, so we are going to go from 0 to, we're going to do this 2 ways. We're going to do our 2 intervals. So I have a note packet here. Let's see. So that went to the 3rd root. Does it let me do a 3rd root on that? Nope. Functions, 3rd root. 3rd root. Ta-da. So 3, and then 1 divided by 4 is how we put in our 1/4, and then that's 0. Okay, so arrow over. Get me out. There we go. So that looks right, 0 to the 1/4. And then in here, this is before our antiderivative, right? That was us doing it by hand. So go back to the original way we set it up was 0 minus our other function. So we are going to do a parenthesis. We'll have minus 8. Okay, minus 8x to the 3rd minus 2, and then end that parenthesis, and then we have to type in a dx, and then it gives me that answer to the 3rd minus, oh, that's a +2. Sorry, it's a +2. I was like I'm looking, the functions are so easy. I was like, that's not the right answer. Crap, did we do something wrong? Okay, so we're at 0.9449, which is what we said. Perfect. Let's do our second one. Go to function, find that sucker again. Here we go. And this time we're going to go find that function. 3rd root again. 3rd root, the very bottom. So 3 inside, 1 divided by 4. And then up here, I need a 6. And you have to use parentheses for the function and then the dx, or it won't activate the answer. And our second function was 8x to the 3rd minus 2, which is what I was looking at. And then put in your dx, and there we go, which does match our answer. And then we can just type it in and add them together. 0.9449 plus 2580.94-ish. Whatever. There we go. Is that what we got? I think that's what we got. 2581.88-ish. All right, let's look back. And that's what it was, right? 2581. Oh my goodness gracious, my memory, 2581. Yeah. Oh, it logged me out all of a sudden. Is that because I was bouncing between 2 things too fastly? Maybe. Okay, so we were able to get that answer. The other thing I want us to try is we could actually try typing in the whole thing instead of breaking it up. Let's see if it will actually do our answer. Hold on a sec, I have to retype into. I think I went too quick trying to figure out, remember if I had the right number on there. Okay, so we're gonna go to Desmos again. And we're going to type in this whole thing. And what I mean by that is we're going to do our integral. Let me find that again here. And we're going to go from 0 to 6. Okay. And then we're going to write in our subtraction for the whole. Oh, you can't. No, just kidding. You can't do it because the other function is, yeah, no, you'll have to do it separately. Yeah, I was trying to think of it easier way. Okay, we're good. Nope, we won't be able to do that. Okay, so that's our answer for that one. Okay, this number 2 problem is really similar. Um, but we can do this one. No, let's do a harder one. Let's do number 3. We'll skip number 2. Number 2 really is almost the exact same problem, which means it's very much doable by hand and on our graphing calculators. Okay, so we're here and we have y equals 8x e to the x minus 5. Definitely an E problem, so definitely want to do this one. And we have a minus 0. So what is the first step when we look at this? Well, our first step should be, I don't know which function's on top, I better graph, okay? So delete all the stuff we had in here. So we have 8 E, just type the regular E and it'll come up to the x power, 8x, okay, minus 5. So this is our function, and then y equals 0, second function. So there's our function, and we're going from 0 to 2. So you can see 0 to 2 right there, right? I can't point it out like I normally because it's in Desmos. So look at the function. The black function stays on top for that whole 0 to 2. If we would have gone negative 2 to 2, we would have had to have 2 integrals again. And we would have had to find where they cross right here and deal with that same thing for problems 1 and 2. But we don't for this one, which is sweet because then we only have one integral and it's an E. So let's set up our integral over here. Our integral will go from 0 to 2. And again, which one's on top? The black one, which is our 8 e to the x minus 5. And then we would minus the 0, this whole thing dx. And I kept the split screen because we can then put this in our calculator right here. So we can say functions, find that pretty one that we really like, 0 to 2, it's one function, so that even makes it easier. Add your parentheses, 8e to the x power minus 5, and then minus 0, whatever, that doesn't really affect it. So there we are. There's our final answer, 41. Okay, so this equals 41.11. So what I love about these is we don't really have to do the antiderivatives on all of them. So when they get harder, we just put them in the calculator, which is sweet for us business people, right? This is going to help us be able to do like continuous income stream, consumer surplus. It is really going to help us with some big ideas that you could use later or not, right? Which is why you're in this course. Okay, so problem 4. So 4 is 2 integrals. I don't know. 4, let's see. Let's do 5. Okay. No, what does this one say? Okay, let's move on to 5. I don't want to do them all just purely because of time for the video. I already can't get y'all to watch the videos very much. Thank you for continuing on to problem 5 with me. I should like give a code word and give you extra credit for actually watching the videos in my online course, or if you're absent from my in-person. Okay, so this one just says these 2 functions. So it's a very different problem. Okay, it just says these 2 functions. The directions will say what area is bounded by these two functions. So it will say area bounded by functions. That's me shortcutting the couple words and by these functions, but so we need to graph these. So we have, go back here, x squared minus 10. There's our first function. Our second one is just y equals 15. If you're putting in just a y, you do have to kind of, you do have to put in the y. If you can't just put in 15, it doesn't work real well. Okay, so here's our two functions. What is the area bounded by these? Can you visualize the area? Well, there's four, there's more than four. There's one section, it comes down like this and it's cut off up here, right? That's our section. So if I was to graph that over here, right, it's looking like this is down at 10, but whatever, just go like this. And we have this here, and this whole section is what we need to find the integral of. So if I'm going to do that, where am I going to start? You aren't given 0 to 10. You have to figure that out. Well, look, where do they cross? They cross here and here. I can see that on the calculator or on the graphing calculators, the intersection points, right? Break even, intersection points. If they are not pretty, you're going to have to set these functions equal to each other and solve. They're super pretty. We can see them. So that's going to lead us to, we're going from -5 to 5. We can see that because they're bounded by those two numbers on our x values. Now the y value doesn't matter. We're talking x values on our integral from -5 to 5 on your x's. And then what function is on top is our 15 function, right? Y. And then we're going to minus off, use a parenthesis when you minus a function, and this whole thing dx. So we can type that in and get our answer. Okay, so functions, and we're going from -5 to a 5, and our function is going to be 15 minus, add a parenthesis, x squared minus 10, parenthesis, dx. Typed it in just like we saw it, and there's our final answer, 166 2/3. Or 0.67 or something like that, depending on what they want. Cool. So I mean, I like Desmos. I don't really care. Graphing Calculator does it too. Now, if you have a very much older graphing calculator on the functions when you're putting them in, when you hit math, right? I wish there was a better way that I could show this. No, I can't really do a camera to this. It goes down to this 9th one. And this was what we will see. See, and it comes up and you have to put in the dx. You can type it all in just like we did. So this last one that we typed in was -5. Now I have to use this negative sign when I type it in because it's in front of a number. And then I can go to 5. And when I type this in, I have 15 minus parenthesis, right? And it was x squared. So use the x by the alpha. To the power of 2 minus 10. And then you have to type in the dx. So x is typed in twice and you hit enter. And you can hit math fraction enter, and you can get the 500/3, right? Which is the 166 2/3. So that one is pretty sweet. All right. Okay. So full screen. Wow, it came, that 166 2/3 came through really big. All right, so we have that one to that one. Let me see. I think you'll be able to handle these. Let's do problem 8. No, this one just says to find the area bounded by the two curves. I like this one because it is a little bit harder to graph, okay? So our function y equals 9x. So I can graph that. It goes through 0, 0. It has a slope of 9. That's up 9 over 1. Oh, that's way up there. Oh, and this one goes all the way 20. All right, fine. I'll just show you on the graphing calculator. Just kidding. I was just going to graph it by hand, but I'm not. Okay, so this one is x to the third and 9x. And they cross like way up here at 27. So that's where I was like, oh, and then I'm like, I'll just show it on here. So look at this weird sucker. Let me close that a little so we can kind of see this. All right, then we have this here and that here. Okay, so we're going to have two different integrals, right? Because you can see we are crossing at that 0, 0. And so we have two functions. So when it just says the area bounded, we actually have two sections and it'll be in between those blue and red lines. So when we go to write this, okay, our first one is going to go from -3 to 0, right? See that -3 to 0. And the function on top is red. Our red function is that x to the third. Okay, so we can see that red function is above the blue. So from that one to that one, we're going to have x to the third minus the 9x dx. And we're going to add that second function. We'll then go from 0, let's look at that one, all the way up to 3. Okay, and so we have to find those numbers. You aren't given from 0 to 3, or -3 to 3. You have to find them. Okay, I'm going to erase this graph because we ended up just having it over there. And then from here, this one is 9x is on top because blue is on top, and you're going to subtract x to the third. And again, this is dx, and we can put this in the calculator just like that with our two functions separately and then add our answers. We can do function, okay, and that function on the first one is going to be -3. Again, you could do this on the graphing calculator handheld as well, to 0. And our function goes x to the third minus 9x and parenthesis dx. And I could then go plus my second function if I so desire, and type them all into one. It's totally fine. And then it'll add them for you. You could do them separate, up to you. Oh, good thing I have one of my students showed me that back button. Otherwise, I'd be annoyed right now. So 9, thank you, student, that figured that out that I never even looked at. To the third. Okay, this one, and again, another dx. Ta-da! 40.5 is our final answer. Cool. And this says compute your answers to 3 decimal places. There's no 3 decimal places. So we could put 0, 0 on there if we so desire. All right, that's this section. Just be careful on the bounded that you find your x to x. Make sure your function's on top. You really have to start with the graph on these, okay? Very heavy graphing calculator section. All right, let me know if you have any questions. I'm here.